If you've been watching the software world, you might think, okay, things have been pretty stable for, what, 70 years? You write code, computers run it. Seems straightforward. Well, get ready. Because that basic reality, it's changing radically, not just once, but actually twice, back to back. We are living through a really, really unique time if you're involved with technology at all. And today, we're going to dive deep into exactly why. Our guide for this is going to be some insights from Andrej Karpathy. You probably know him, former director of AI at Tesla. He's put together this really helpful framework for understanding this huge evolution and how software gets made and how it runs.
Yeah, it's a great way to frame it. Karpathy talks about these three eras of software. The first one, software 1.0. That's the classic stuff. It's the code humans write directly. Think C++ for the early Tesla autopilot systems. Your standard GitHub repositories. That's software 1.0.
Okay, so that's the code we all kind of grew up with, the explicit instructions. How fast did things start shifting from that to the next stage?
Actually, pretty quickly in the grand scheme of things. That brought us to software 2.0. And this is the world of neural networks. Here, you're not writing code line by line in the same way. It's more about gathering huge amounts of data, designing network architectures, and then running optimizers to train the network, finding the right weights.
Weights, right.
Think of Hugging Face maybe as the GitHub for this kind of software. AlexNet is a classic example here, the image recognition network. Though until quite recently, these were mostly, fixed function, really good at one thing, like image classification, but not generally programmable in the way we think now.
And now we get to the really mind-bending part. Software 3.0. This is the latest shift, driven by large language models, LLMs. And the big deal here, Karpathy says, is that these models are now programmable using just natural language, like plain English prompts. The idea of telling a computer what to do in just normal language, that feels huge. How big a deal is this really for access, for innovation?
It's massive. He calls it an entirely new kind of computer. Your prompt is the program. It fundamentally rewires that human-machine interface.
So what's the mission for you listening in today?
Well, our goal is to help you really get your head around this new way of programming, to understand what these LLMs actually are as this new kind of computer, figure out how to work with their unique psychology, and see the huge opportunities opening up. And Karpathy uses some great analogies. We'll explore things like utilities, factories, and maybe the most powerful one, operating systems from the 60s.
Yeah, and we absolutely need to dig into that psychology. They're almost human-like quirks. They have these incredible superpowers, but also some really surprising cognitive blind spots you have to know about if you're going to build with them.
Right. So whether you're maybe thinking about getting into tech or already in it and wondering how things are changing, or honestly just curious about how all this stuff is reshaping daily life, understanding these shifts is becoming pretty essential. Karpathy actually saw this shift happening firsthand at Tesla, right, with autopilot. Exactly. He describes how the software 2.0 stack, the neural nets, literally started eating the software 1.0 stack.
Yeah.
Capabilities that were first built in C++ were gradually replaced by trained networks because they often performed better, especially for perception.
So what's his prediction now with Software 3.0 entering the picture?
He thinks we're seeing it again. Software 3.0, the LLMs, are starting to consume parts of the stack that used to be 1.0 or 2.0, which means, we now have these three totally different ways to program coexisting, and being fluent in all three is becoming key.
So it's not just about picking one.
No, it's about making smart architectural choices. When should this feature be explicit code? When should it be a trained neural net? And when should you just, prompt an LLM? Moving fluidly between these is like the new core skill for developers.
Okay, so let's talk about this new LLM computer. What is it like? Those analogies sound helpful.
Yeah, they really are. First, he points out they act a bit like utilities. Think about OpenAI, Anthropic, Google. They spend billions on CapEx, the capital expenditure, to train these huge models. That's like building the power grid. Then there's the OpEx, the operational cost, to serve that intelligence through APIs, where we pay, per token, like paying for electricity.
And we expect the same things, right? Low latency, high uptime, consistent quality.
Exactly. And you can even switch providers, like using OpenRouter to route API calls, similar to maybe having a transfer switch for different power sources. And it's fascinating because, unlike physical utilities, they don't compete for physical space. You can have multiple global providers.
And we've felt that utility aspect already, haven't we? When a major LLM goes down, it feels like an intelligence brownout across the world.
It really does.
The more we rely on them, the bigger the impact. It shows how fast they're shifting from just tools to actual critical infrastructure. Reliability becomes a huge global issue, almost like the power grid itself.
Absolutely. And that brings a whole new level of responsibility and vulnerability too. Beyond utilities, he also draws a comparison to fabs, semiconductor fabrication plants.
Okay, how so?
Well, the capex, again, is enormous, like building a chip factory. And there's this rapidly growing tech tree of R&D secrets inside these big LLM labs, kind of like the secret sauce in chip manufacturing.
But software is easier to copy than hardware, right?
It is, yeah. So the analogy isn't perfect. Software is more malleable, maybe less defensible long term. But you see parallels. Like
Yeah.
using NVIDIA GPUs is kind of a fabless model, whereas Google training on their own TPUs is more like Intel having its own fabs.
Yeah.
It's about controlling the underlying hardware.
Interesting. But the analogy he finds most compelling, and I think I agree, is likening LLMs to operating systems from the 1960s. Why that comparison?
Right, because they're not simple commodities like electricity. They're becoming these incredibly complex software ecosystems.
Hmm.
Think about it. You have a few big closed-source OS providers, Windows, Mac OS, and you have an open-source alternative, Linux.
Oh.
We're seeing a similar structure emerge with LLMs, aren't we? A few big closed-source players, and then the Llama ecosystem is maybe looking like an early Linux for LLMs. And we're still super early. These things are getting way more complex, adding tool use, multimodality. The LLM itself acts like the CPU. The context window is like the RAM or memory, and it orchestrates everything to solve problems.
Yeah, when you use a good LLM now, it feels like there's a central intelligence coordinating things.
And another 60s parallel, LLM compute is still really expensive.
Mm.
So it's mostly centralized in the cloud. We're all basically thin clients connecting over the network using time sharing. That's exactly how computing worked before personal computers took off.
So the personal computing revolution for LLMs hasn't quite happened yet.
Not fully. People are trying, running models locally. Macs with unified memory are surprisingly decent for some tasks, but we're not there yet for the most powerful models.
Karpathy mentions interacting with ChatGPT feels like using a 1960s terminal. What's the point there?
It highlights that we haven't really invented the standard graphical user interface, the GUI, for LLMs yet. Beyond just chat bubbles, we're still mostly in, like, command line mode, typing text prompts.
There's also that interesting flip in how the tech spreads, right? Usually big tech goes government, then corporate, then consumer, but LLMs went consumer first.
That's a great point. We were all asking ChatGPT how to boil an egg or write emails before many companies really figured out how to integrate it systemically.
Yeah, corporations and governments are kind of playing catch up to us, the users, which probably shapes where the first really useful applications are showing up.
Definitely.
So, okay, LLMs are like these complex early stage OSs delivered like utilities. That's a massive conceptual shift, especially how fast they reached billions of people.
Yeah.
And this accessibility opens up these huge opportunities for programming them. But first, we need to grapple with their weird characteristics. Karpathy calls them stochastic simulations of people.
Yes, exactly. Because they're trained on basically all the text humans have put online, these autoregressive transformers develop this emergent, almost human-like psychology, which gives them incredible superpowers, but also these really weird cognitive deficits. Understanding both is crucial.
Superpowers seem obvious, massive knowledge, perfect recall, like Rain Man remembering phone books, as Karpathy puts it. They know more facts than any human.
Definitely superhuman recall and breadth of knowledge, but then the deficits.
Right, the downsides.
First, they hallucinate. They just make stuff up, often very confidently. Their internal model of what they actually know isn't perfect, though it's getting better all the time.
We've all seen that. Confidently wrong answers.
Yeah. And then there's jagged intelligence. They can solve incredibly complex problems in one area, but then make kindergarten-level mistakes in another, like insisting 9.11 is bigger than 9.9 or misspelling simple words like strawberry. You can easily get tripped up by these rough edges.
And the big one, maybe the most fundamental difference from humans, anterograde amnesia, as he calls it.
That's key. Unlike your human colleague who learns, remembers past interactions, builds expertise, LLMs don't do that by default. Their context window is like working memory, but it gets wiped clean after each interaction, unless you explicitly feed prior context back in.
Which explains why people get frustrated when they expect the LLM to just remember the last conversation or get smarter on its own.
Right. He uses analogies like the movies Memento or 51 First Dates. The knowledge base is there, but the short-term memory resets constantly. It's hard to build relationships for complex projects like that.
And security is another one.
Yeah, they can be quite gullible, susceptible to prompt injection where malicious instructions trick them. and they might inadvertently leak private data if you're not careful about what you put into the prompt.
So the real challenge and also the opportunity is figuring out how to program these superhuman, amnesiac, sometimes hallucinating, jaggedly intelligent entities.
To get useful work done, safely leveraging the superpowers while carefully managing the deficits. That's the game right now.
Okay, so how do we start using them effectively then, given all that? What are the big opportunities Karpathy sees for building useful things?
One of the biggest areas he points to is what he calls partial autonomy apps. The idea is, instead of just dumping everything into a general chat interface like ChatGPT, you use specialized tools.
Like Cursor for coding.
Exactly. Cursor is a prime example he mentions. It keeps a familiar coding interface for manual work, but seamlessly integrates LLM help for bigger chunks. It's getting real traction.
And what makes these apps work well? What are the key ingredients?
He highlights a few things. One, the app manages a lot of the context for you. You're not constantly copy-pasting file contents or error messages. The app knows the context. Two, they often orchestrate multiple LLM calls behind the scenes. Cursor might use an embedding model, a chat model, a code diff model, all coordinated without you needing to manage it.
Okay, so context management and orchestration. What else?
A really crucial, maybe underappreciated part is the application-specific GUI, the graphical user interface. You don't want to just talk to the OS in plain text all the time, especially for complex tasks. Reading long text outputs is slow and error-prone for humans.
Right, like trying to review a massive code change as just a block of text.
Exactly. A good GUI, like showing code changes with red and green diffs, lets a human audit the AI's work much, much faster. Our visual processing is high bandwidth. You can accept or reject changes with a click, not by typing out instructions. It massively speeds up the human supervision part.
Makes sense. And then there's the autonomy slider.
Yeah, that's a great concept. In Cursor, you can choose the level of AI help. Simple tap completion is low autonomy. Command-K to change a function is more. Command-L for a whole file. Maybe Command-I to let it work across the whole repository. That's high autonomy.
So you control how much you let the AI do based on the task or how much you trust it at that moment.
Precisely. Perplexity, the research assistant app, has similar features, right? It packages info, orchestrates LLMs, has a GUI with citations for auditing, and different modes for quick or deep research. That's the autonomy slider again.
This really poses a big question for anyone building software now, doesn't it? How are you going to make your product partially autonomous? Can an LLM see what a user sees in your app? Can it take the actions a user can take? And crucially, how do you design it so humans can effectively supervise and stay in control, given these things aren't perfect yet?
It implies that software that was just designed for human eyeballs and clicks now needs to be rethought to be more accessible and understandable for AI agents too.
And that human supervision part, the generation verification loop, that seems critical.
Absolutely. The AI generates something, the human verifies it. The whole goal is to make that loop as tight and fast as possible.
Which is where GUIs come back in.
Yes. GUIs leverage our visual system, making verification much faster and, frankly, more pleasant than reading dense text outputs.
It also means keeping the AI's output manageable, right? Getting a 10,000-line code diff isn't helpful if it takes you days to review it.
Exactly. You become the bottleneck.
Right.
So you need to work in smaller, verifiable chunks. Keep that loop spinning fast. Iterate quickly.
And be specific with your prompts.
Crucial. Vague prompts lead to bad generations, which fail verification. You waste time. Spend a bit more effort on a precise prompt, and you dramatically increase the chance of getting something useful you can quickly approve. Like in education, just asking an LLM to teach me physics is too broad. It'll likely generate something you can't easily audit or learn from effectively. Better to structure it. Give it a syllabus, ask for specific modules, create verifiable learning steps. Keep the AI on track.
Karpathy's Tesla experience seems relevant again here. Autopilot had a GUI showing the AI's perception, and the driver is the ultimate supervisor, the autonomy slider.
Right. He mentioned that impressive 2013 demo of self-driving, thinking full autonomy, was just around the corner.
And here we are, over a decade later. Huge progress, but still humans-in-the-loop teleoperation needed sometimes.
It underscores the difficulty. If driving, a complex but physically grounded task, takes this long, why the hype about 2025 being the year of agents for everything else? Karpathy suggests it's more like the decade of agents. We need to be patient and really focus on keeping humans effectively in the loop. It's still software, and software is tricky.
Which leads perfectly to that Iron Man suit analogy he uses.
I love that one. The suit augments Tony Stark,
Yeah.
lets him do amazing things, but he is still driving it most of the time. It can be autonomous, but the primary value is augmentation.
So the message is focus on building those Iron Man suits for people right now. Tools that make humans faster, smarter, more capable.
Exactly, especially tools with great custom GUIs and UI/UX that accelerate that generation verification loop. Offer the autonomy slider, sure, but focus on augmenting the human first, not replacing them with flashy demos that don't quite work reliably yet.
Okay, that makes a lot of sense. Build the augmentation first.
And then there's the other truly wild dimension. These things are programmed in English or other natural languages, which means, kind of suddenly, everyone's a programmer now.
That sounds incredible. Like potentially one of the biggest shifts ever in who gets to create software. It used to take years of specialized training.
Right. Have you heard people talking about vibe coding? It became
Mhm.
this huge meme because it captured that feeling. Everyone had this almost magical sense of just describing what you want and having software appear.
Yeah, conjuring apps with words.
Karpathy is pretty excited about it. He saw Tom Wolfe from Hugging Face share a video of kids vibe coding, calling it a gateway drug to software development. He's actually quite optimistic about what this generation could build. It's not all doom and gloom.
Did Karpathy try it himself?
He did. He built a basic iOS app without knowing Swift, and another little tool called MenuGenin, which generates images for restaurant menus. He just described them. And it worked. He got the basic iOS app running in a day, and MenuGenin worked too. But what was fascinating there, the code generation for MenuGenin was the easy bit for the LLM. The hard part, the part that took him another week, was making it real.
Hmm.
Setting up authentication, payments, domain names, deploying it, all the DevOps stuff.
Ah, the stuff that isn't just pure code.
Exactly. And a lot of that involves manually clicking through web interfaces, following instructions written for humans like, go to this URL, click this dropdown. It was like the computer was giving him, the human, instructions to act like a robot.
Which raises a huge question. Can we eventually get agents to do that tedious, clicky work too?
That's the next frontier. Thinking of agents not just as code generators, but as a new kind of digital information consumer and manipulator. They're computers, but they need to interact with systems designed for humans.
So how do we help them?
Well, we can start building for them. Just like websites have robots.txt to guide web crawlers.
We could have lm.txt files.
Exactly. Simple markdown descriptions of a domain or API. Much easier and more reliable for an LLM to parse than complex HTML or UIs. Think about documentation. So much of it is written for humans, lists, bold text, screenshots. Services like Vercel and Stripe are already starting to offer separate docs specifically formatted for LLMs, often in Markdown. They even replace click this button instructions with the equivalent curl command an agent can execute directly.
That makes so much sense. Instead of teaching the LLM to read human docs, give it machine-readable docs.
Yeah. Karpathy did this himself. He copied all the docs for the Manam animation library into an LLM, described the animation he wanted, and bam, it generated the script. It vibe coded the animation by reading the LLM-friendly docs.
Wow. Making existing software documentation legible to LLMs could unlock a massive amount of functionality.
Huge potential there. And tools are popping up to help, like services that take a GitHub repo URL and just concatenate all the code into one big text file formatted for an LLM.
Sure.
Or even tools like DeepWiki, which Karpathy mentioned, that try to automatically analyze a repo and generate documentation for the LLM.
So while maybe one day LLMs will be amazing at navigating human UIs, the faster path right now is to meet them halfway.
Exactly. Make information easily accessible to them. It's incredibly valuable, especially for the long tail of software that might not get a full agent-focused redesign anytime soon.
Okay, let's try to wrap this up. It feels like we've covered a huge amount of ground.
We have. So the big picture, we're undeniably in this period of profound change for software, moving from software 1.0, the handwritten code, through 2.0, the neural networks trained on data, and now into 3.0, these LLMs that we program with natural language.
And understanding LLMs means seeing them as these new, complex, almost 1960s-style operating systems, delivered like utilities, but with this strained, emergent, human-like psychology.
Right. Complete with both amazing superpowers and these critical, sometimes frustrating fallibilities like hallucination and amnesia.
Which then points to the practical opportunities. Things like building those partial autonomy apps with smart GUIs and that crucial autonomy slider, and embracing this wild idea of vibe coding that lowers the barrier for creation while always remembering the need for human oversight, keeping the human on the leash, so to speak.
Yeah, and also the value in designing things like documentation specifically for agents to consume easily.
Bringing back that Iron Man suit idea one last time, it really feels like the right focus now is on building powerful augmentations for humans. Tools that amplify our abilities, speed up that generation verification cycle dramatically, rather than chasing fully autonomous agents before the tech is truly ready and reliable.
Absolutely. And that leads to the final thought, maybe. Karpathy says this is the decade of agents, and he's likely right. But it's not about just handing everything over. Instead, for you listening, you're stepping into an era where the key skill is learning how to thoughtfully, carefully slide that autonomy slider, knowing when to let the AI take the lead, when to pull back, how to supervise effectively. The challenge and the opportunity is designing and building that future software where humans and AI collaborate seamlessly, leveraging the best of both. It's about finding that perfect balance on the slider,